Thank you for surviving this long day and coming to my talk. I know that there's been a lot of talks about AI today. I think I counted 7 or 8, so I hope you don't feel like the like this picture. Everyone pushing AI from everywhere. Now, sorry that I will be doing the same. Hopefully, you will find it more entertaining than other talks. Now, I also noticed that a lot of people voted for AI being an opportunity rather than the threat. There are some people in the middle, so hopefully I will be able by the end of the talk to change your mind, and hopefully not from the opportunity to threat, but in the other direction. But yeah, so basically my talk today is about coding assistants, and I'm guessing you are all, or most of you are developers. And the agenda for today, basically, we will go through sort of a small time travel. We will talk about past, and we will talk about why we need to even go beyond Copilot. We will talk about present, we will talk how we can go beyond Copilot, and then we briefly talk about what's next for you, for the developers, and will AI finally replace us programmers in our everyday life. Now, before we go beyond the agenda, can I get actually a show of hands from people who use any coding assistant in their everyday life? Okay, quite a lot of you. All right. And then can I also get a show of hands from people who use anything else other than Copilot or ChatGPT? Okay, all right, great. Okay, so let's, I guess, quickly skim through the first couple of slides, just to make sure that, just to make sure that we are on the same page. Code assistants, as you probably know, they provide a lot of potentially useful features for you as developers. So they can generate code for you, and it can come in different flavors. It can be code completion, where you just start typing something and you get suggestions on how to finish that line of which you are typing. It can also generate code from scratch from the natural language request, which you asked it to do. Let's say, I don't know, generate a Fibonacci sequence generator or whatever. Then there is also, of course, code editing capabilities, where you can ask code assistant to refactor the code for you, change it, modify it somehow. For example, I don't know, to select a different library, or use a different library, or maybe optimize its running complexity, and so on. Then, of course, there are features around code, but which don't really produce the code. For example, documentation generation. And of course, some assistants also provide you with the ability to do error detection and correction. So they can highlight any potential bugs, any potential errors, vulnerabilities in your code, in your repository, and sometimes they might suggest even the fix for that. Now, this definitely sounds promising, but unfortunately, in reality, it's not as bright. So you can get a bunch of code from the chat, from LLM, but then you will need to spend, some time, depending on the length of the code, on the complexity of the code, trying to understand what the hell even the LLM produced for you. And sometimes you might even discard it completely, and that's actually indeed the case. So there are several studies on how introduction of coding assistants actually affected everyday life of the developers. And there are certainly some pros for using Copilot or other competitors of Copilot. So there is, of course, a lot of reports of developers being able to complete tasks faster. There is also sort of perceived productivity improvement, and in general, people say that they feel more confident about the code. Unfortunately, if you look at the longer scale, we will see that since the introduction of any coding assistant like Copilot or whatever you use, they basically code churn rate essentially doubled. So in 2 weeks, the code, half of the code which was produced by any coding assistant will either be heavily modified or completely removed. And the stats are not very promising right now, right? So now, why is that? Well, first and foremost, coding assistants are usually employing the LLMs, large language models, which in its nature are trained to predict the next probable symbol. And what this means? So let's say you are typing the word class, you start typing CLA, then the most probable token, the most probable symbol would be SS, because class is pretty much common word in any programming language, right? And that's also true when you try to generate code, when you try to generate documentation. As long as the things which you try to generate are present in the training data, and those models are usually trained on open source data. So basically, as long as the code you generate is present in the open source, or it is similar to what you can find in open source, then you are fine to some extent, right? Unfortunately, once you start trying to use it for your maybe internal frameworks and so on, like basically any code which LLM didn't see in the training data, in the open source data, then they will start to fail, because they essentially don't know anything about your internal frameworks, about your libraries. And what is more, so let's say for some reason one of the frameworks, one of the testing frameworks is much more popular than another one. So let's say PyTest is much more popular in the open source, right? And then your code base is actually using unit test. Now, because of the nature of the LLMs, you will get more tests for the PyTest, which essentially will be useless for you because you are using unit tests, for example, or other framework which is anyway less popular. So that's essentially one problem. And yeah, obviously, if you're using your internal code bases, any open source LLMs, any third-party providers like OpenAI, Anthropic, they don't have access to that, to your documentation, to your code base, to your frameworks. So they essentially don't have no knowledge, no clue about them. But that's not all. So there are also other sort of failure modes for LLMs. Well, first of all, they struggle with logical reasoning and things like some phrases which might sound kind of quirky for human ear, but still completely logical. Like Tom Cruise is the mother's son. It does sound a bit off, but still it's completely valid phrase. But still, they unfortunately confuse the hell out of LLM. And like here's an example from O1 preview, which is supposed to be the most advanced model from OpenAI. Unfortunately, it sort of still kind of fails, even though it thought for like 10 seconds. And obviously, we as humans, I would hope nobody thought for 10 seconds to answer that question. So basically, even the best LLMs out there, again, O1 preview is supposed to be one of the best LLMs out there right now. They still fail. It takes them a bit longer to hallucinate the errors. And yeah, so on top of that, again, they don't have grounding on the physical world. And what I mean by that is, again, they basically don't know anything about your environment. They don't know what kind of tools you use, what kind of dependencies, a version of those dependencies, and whatnot. So they basically are essentially, going blind every time you ask them to generate anything. And you can think about this as sort of this 51st dates or 51st tasks situation, where you just pick a random person from the street, a random developer from the street. You sit them in front of the computer. You don't give them any context, any knowledge about your company whatsoever, but still you give them the task to fix in your code base any bug, or you want them to introduce any feature in your code base. Obviously, they might produce some results. They might even be good. They might be bad, but without any knowledge of your, again, about your frameworks, about your typical guidelines, code styles, and whatnot, they most likely will produce the solution which you will need to also modify or even completely discard. So essentially, in the end, you will probably not be happy with the solution. And this is essentially the case with the coding assistants right now, where every time you ask them to generate anything, they just go blind, give you something without any grounding in the physical world. And yeah, you might like it, you might not, but overall, as you've seen in the stats, the code churn essentially increasing, and obviously it's not a good thing that you would need to spend more time, even though on the shorter scale, you feel like you've saved it. And then the last one, which I've already talked about, is essentially they work well in the distribution. So as long as your task you want them to do, as long as your code similar to open source data, right, to basically to data which they were trained on, you're fine. But then, unfortunately, as long as you start using any internal frameworks, any new frameworks which weren't part of the data, well, they basically will start fail you. So now let's actually diverge from LLMs for a second, and let me ask you this. So how do you think, what do developers spend most of their time on? And it's not drinking coffee. So any ideas, what do developers actually spend their time on during their work hours and maybe outside of, sorry? Reading code, okay. Yeah, that's actually pretty much true. It's called, in this case, it's called understanding. So basically there was a study in 2015 where people looked at what developers spend most of their time at. And as you can see, actually editing code over here is just 5%. A lot of time is spent on understanding the code, or maybe understanding requirements, understanding what the hell product manager asks you to do. There are some things outside of IDE and UI interactions, so think like some kind of tools, like maybe Googling something, searching for answer in Stack Overflow, using debugger, and so on. But again, current code assistants essentially focus on those 5% of your time, completely discarding pretty much the rest of 95%. Now, what can we do about this situation and all the drawbacks which LLMs have right now, which I just talked about? Well, let me go to the present part of the presentation and talk about how we can address those issues. Let me introduce the thing called AI agents. Finally, it wasn't in the name of the talk, so we are now getting to the agents. So AI agent is basically a software which is supposed to perform tasks on behalf of the user. And this might sound pretty much the same as a coding assistant, as an LLM, right? However, AI agents possess several key features or design patterns which sort of differentiates them from a regular LLM, from regular software. And there was a good analogy of AI agent with a robot vacuum cleaner. And essentially, you can think about any Roomba or whatever you have at your home vacuum cleaner as an agent. So basically, there is a software which runs on top of the vacuum cleaner. However, it would be pretty useless if it only could point to the patches of dirt and couldn't do anything about it, right? Now, what basically enables the robot vacuum cleaner to be helpful? Well, first of all, it has tools. It has brushes, it has wheels, it can move around, it can, well, clean the floor, clean those patches of dirt. Then, of course, there are some planning steps. So they don't just randomly, walk around the room, the apartment. They try to find the best plan of movement, the best sort of directions, which would cover the most area in the shorter amount of time. And well, not in the case of Roomba, but of course they can also interact with the environment, with the other agents, other vacuum cleaners. And those are actually all the things which AI agents possess. So there is tool use. So you can think about using debuggers. You can think about using browsers and whatnot. In the case of development, there is of course also a step of planning. And we as humans, of course, also do planning when we think about tasks, even subconsciously. We don't just start randomly type. We don't just start randomly type something. We first think, okay, so I will do that first, then I will do this, and so on. We also try to reflect, hopefully, on our solution, on our plans. So we can, talk with a colleague about our plan. We can even, think ourselves if this is a good plan or not. And of course, there is a multi-agent collaboration. And again, you can think about it as either multiple agents talking with each other, or you as developers talking with each other as well. So like backend engineer talking to front-end engineer or product manager and so on. And together you are coming up with a solution which ideally will solve your task, your problem at hand. Now let's go back for a second to this diagram, and we can actually quite easily see that all those patterns, they pretty much overlap with this diagram over here. So of course, the tool use, we use tools for editing, but we also use tools outside of IDE for UI interactions and so on. Then, of course, there is a planning step, which of course will require understanding of the code, right? But then also might require some tool usage, some editing, and so on. Reflection, of course, it's hard to reflect without understanding the actual code base. And well, multi-agent collaboration pretty much involves all of the things over there, but most importantly, of course, the understanding part. Now, okay. Now let's actually do some coding, and I will be doing that in Python. Sorry for those who don't know Python, but it will be pretty easy to follow. So let me switch to my code here. So it is pretty straightforward. I will be essentially talking with OpenAI LLM model, and I will be essentially just asking several questions, which are pretty straightforward for us, for the people to get answers to. So in this part, I just create an OpenAI client, and I hope internet connection won't fail me. But yeah, basically we can ask things which we, again, as people can do pretty easily, right? So let me actually zoom in a bit over here. Yes, so let's say what's the response time for google.com? It's pretty easy to find out for us. Unfortunately for LLM, and I hope internet connection works. Yeah. So unfortunately, LLM, ChatGPT doesn't have access to real-time tools, real-time capabilities, so it can't provide any answers for that. I can't also, it can't also tell me what kind of Python packages I have, so because it, again, doesn't have any access to my environment, to my laptop. Yeah, so unfortunately, it doesn't have any access whatsoever. It does provide some commands for me to use, but obviously it's not the same. And of course, they also lack some knowledge. So I think Python 3.14 is not yet released, if I'm not mistaken, or maybe it was released like in November. But again, because LLMs, yeah, so unfortunately, LLM is out of date for like a year already, and Python 3.14 wasn't released then. So it can't give you any answers. It looks like it tried to give some answers about Python 3.10, which obviously not very helpful for us. And then, of course, we can also ask when is the conference, which we are attending right now, is happening. And again, unfortunately, well, it is indeed in 2024, which wasn't the answer, but it's not really helpful for us. Now, what can we do about it? So essentially, we can, for example, give the LLM an option to use tools, and it's pretty straightforward. Now, again, I will create an OpenAI client over here, and I will use what is called React framework. So basically, React stands for Reason Plus Act, and it consists of several steps which we ask LLM to perform on our behalf. First, it needs to think on what kind of action it needs to perform in order to achieve the result, in order to give you the answer to its question. Then it needs to decide which action it needs to perform, which is essentially an action step. Then there is a pause where this action is supposed to happen. So basically, LLM will wait for the result of that action. Then there is observation, where LLM analyzes the result of the action, and hopefully it will get you the answer, or it might go into the loop again if it decides that it didn't get enough information, and it might might need to use another action, or might need to rephrase the question, and so on. Now, it is pretty straightforward to actually implement this. There is this system prompt, which you can quite easily actually also found on the internet. But essentially, we just conditioning LLM to do exactly what I've just described, it will first think out loud what kind of action it needs to perform. And we are providing a list of actions over here. So it can do the ping, it can run bash commands, it can do web search. And every time it needs to use any of those, there is special syntax for LLM to use. So name of the command, semicolon, and then, for example, in this case, the website it needs to ping. And there is also example session for LLM to be more, to understand better. Essentially, for example, in this case, we will ask the question, how many islands make up Madeira? I live on Madeira, so that's why it's there. So basically, LLM ideally should think, okay, so I need to do a web search on Madeira to find the answer. It will perform essentially the action, web search Madeira. It will wait for the result. And then once it gets the result, it will get observation where hopefully on the website it says, Madeira is made up of 4 islands, yada, yada, yada. And it will give us the answer to our original question, 4 islands. So let's execute this cell as well. Now this is just a helper function to essentially just send request to the model. And here's our actions, which LLM will be able to perform. It's pretty straightforward. Ping, we can run bash command, and we can do the web search. We will just use the first result from the Google search. So let's test them. So, for example, we can ping PyCon conference. We can check the Python version. I have in this case Python 3.12.6, and we can do web search again for the same question. And here's basically the result of the web search, and we can go to that web page, which indeed is for Madeira Island. Now let's see how our LLM can now leverage those tools at its disposal to give us much better results, much better answers to our questions. So here's just a helper function again, and this function essentially just implements the React loop, where we just again ask LLM to perform the user query, the user question, and then we go into the loop until the LLM is happy with all the information and it has given the result. It is again pretty straightforward. We just try to find what kind of action it wants to perform over here, and then we actually perform that action, provide LLM with observation, and hopefully get the answer. Now let's again try the same examples which we just did. Let's see if we can get the response time for Google. So okay, so I need to find the response time. I need to use ping command. Then LLM asks to perform the action, ping google.com, which we do, and we got the observation. And now LLM essentially can answer that same question, which we just couldn't answer just a minute ago. The same goes for the Python packages. So I can essentially just give the access to my environment, to my laptop for LLM. So in this case, it decides that it needs to run pip list, which is pretty much the command indeed which it needs to run. And yeah, here we go. It now has the understanding of my environment. It now understands what kind of packages I have, versions, and so on. Of course, we can also ask what's new in Python 3.14. Let's see if it will be able. Yeah, so it decided to perform the web search, found all the necessary information over here, and there is somewhere down below under the web page there is an answer. So there are some new features for the evaluation and so on. And then, of course, we can leverage that to also get up-to-date knowledge on any events happening right now. Like again, in this case, the Porto Tech Hub Conference, there is a website, and here's our date, which is, I think, is indeed today, November 26, 2024. And now you can imagine those tools, those actions, being not just actions, not just bash commands, but they can also be pretty much anything you can imagine. You want LLM to be able to do. They can also be agents on their own. So you can imagine sort of like a top LLM or being a product manager, then it having at its disposal any engineer agents like backend engineer, front-end engineer, DevOps, and so on. And then those agents, those engineers can on their own also call other agents. So basically, you can imagine this hierarchical branching structure of agents all working together on behalf of you as a user to basically achieve any bug fix, any new feature implementation which you ask them to do. Now let me go back to my presentation over here. Let me go back to slideshow. Now it was pretty easy, and you can of course also play around with this code as well. It's available on this link, on this QR code over here. You can try to implement much more sophisticated tools, much more sophisticated actions, implement agents, and so on. There are, of course, some open source tools available for that as well. Most notable are SWE Agent and OpenHands, formerly known as OpenDevin. But of course, you can also start using agents already today without any hassle with our product, Zencoder. So basically, what we do as part of our product, we try to leverage enhanced context and AI agents to integrate into your environment and help you get much better code generations, much better results from code assistant than you could get from other previous generation competitors. So let's get back to us for a second to our 51st date scenario over here. Now, in case of Zencoder, we of course first collect intelligent context, and that could range from, let's say, specific parts of the file which might be important, might be relevant to your question, all the way to information about the environment, about tools you use, build tools, unit testing frameworks, and so on. Then this already reduces the errors from LLM, reduces the hallucinations, which of course you've just seen in the example. It now has access to more information, and this always helps. But then on top of that, we also have what we call agentic repair pipeline, which basically allows us not just simply generate the code. We don't just stream the code for you like you've seen in ChatGPT or Copilot or whatnot. We also try to run it. We try to compile it to make sure it actually works, it actually runs. And because we also know about the environment, we try to run it essentially in your environment so that it is tailored pretty much to your specific code base, your specific project. Yeah, hopefully it also makes you happy in the end. Now let's dive into some couple of demos over here. Let me, oops, sorry. Yeah, so basically the first one is unit test generation, and let me scroll back a bit. So we, in our case, in the case of unit test generation, we don't just start streaming the code right away. We first start with the planning step. So basically we create this test plan for you to either edit, or you can also add your own test cases, your corner cases which you might want to cover with the tests and so on. Now, once you're happy with that, we of course also generate the code, but again, as I said, we don't just simply stream it. We have the whole pipeline of the steps which we can leverage based on your environment to make sure that the code actually works, actually runs. So in the end, you get the code, which you don't need to spend time on debugging. You don't need to spend time on finding any errors, any bugs from LLM. You just get the code which essentially actually works, actually runs. And then another example over here with the code improvement, where basically we can ask Zencoder to optimize or refactor some of the code. So again, just in the natural language form, we will ask Zencoder to rewrite these. Oh, sorry, why it keeps restarting? I'm not sure. We will just ask Zencoder to rewrite code using JWT library. So in this case, this file is all about working with JWT tokens, and the function over here is written in probably not the most efficient way. And it can essentially be replaced with a single line of code, which we essentially ask the encoder to do. So, sorry, I'm not sure why it keeps. Okay. Yeah, and again, as you can see, we don't start streaming the code right away. We first make sure that it actually works. So in this case, we no longer needed those libraries, like base64.json. We no longer need them. And the code itself now is essentially just a single line of code over here instead of whatever 6-7 lines, which we had before. And it actually uses a library which is designed for those things. So you can imagine this tool being used, for example, for converting legacy code from old versions to new versions of the libraries, or I don't know, from one language to another for whatever reason, if you want to do that. And yeah, again, as you've seen, we don't just simply generate the code, we try to fix it for you. Now, let's talk briefly about the future and what it holds for you as developers. And there are actually two different opposite views on what the future holds for us as developers when we talk about AI being introduced into programming. Of course, there are some people who think that they will get replaced finally, or however you want to think about it. And maybe it's a good thing. Maybe you can finally go chase the goose farmer thing you always wanted to do, or whatever your guilty pleasure is. Now, of course, unfortunately, like on the other side, of course, you can't really train the models without actual code. So you still you still need someone to be able to write that code for LLMs, yet at least. So yeah, basically the second point of view is that instead of you being replaced, you would be sort of moving more towards kind of managerial side of things. So you would have a lot of virtual juniors, a lot of junior engineers at your disposal, to which you will be able to essentially offload your mundane tasks, your repetitive tasks, like writing documentation, writing unit tests, and let's be honest, nobody likes doing that. So yeah, basically you will become kind of a manager of huge virtual army of your own agents, of your own virtual developers. And yeah, basically you would be just telling them in the natural language form what you want them to do, and they hopefully will get you there, hopefully without introducing bugs which will crash half of the world. But yeah, basically that's the thing which we are trying to achieve at the encoder, give you the option to basically have a virtual army of developers at your disposal. And if you want to try us out, you can do that through this QR code over here. We just went public last month, but yeah, we have a free plan if you want to try us out. Basically, you get 2 weeks of free trial, and then you can decide for yourself if you want to switch to the free plan. If you want to switch to a paid plan, it's up to you. Our free plan is forever free, so you can use it for free as well. And with that, I think that's all I have for today. Yep, we'll be happy to answer your questions. Do we get a microphone for the questions? So, okay, I guess. Yeah. Yeah. I think you've been the first one. Okay. Mm-hmm. Mm-hmm. Yeah. So on the model side of things, we actually use a mix of models because, as you've seen, we have a pipeline of different steps, and some models work better on some steps, and then for other steps we might use different models. So we basically try to mix and match all the models to make sure that the result of the pipeline in the end is as good as possible. Now, on the cost side of things, it really depends. So for example, with the agents, obviously it can scale up pretty fast. right? So if you, for example, trying to again do this React framework, which I've just thrown, and you have a lot of agents talking to each other, obviously it can become quite expensive pretty fast. But yeah, I think again, if you look at the trends of how the cost for tokens changed, you will see that it actually been reduced by 50% every like half a year. So for example, I think initially GPT-4 was what, like $10 per 1 million token. Now GPT-4o is what, $3 if I'm not mistaken, something around that. And there are obviously also much cheaper models. So the hardware becomes faster, hardware becomes better, models become more optimized. So I think we still, even if now it might look quite expensive to run agents, I think in a year or two we will get at the level where you would be able to also even run it on your local machine, pretty much. No, you just pay for the subscription and that's it. Yep. Okay. Yep. Mhm.
Okay, no worries. The agents are specialized, let's say, per task.
Yep.
If you guys have already agents for example, to assist on code review activities,
Mhm.
and the second part is the how do you guys handle data privacy?
Okay, yeah, so on the agent part, so first of all, we have some agents predefined already for you. So like coding agent, unit test agent, but we also provide an option for you to create your own custom agents where you can basically just give it a name, give it a command instructions. Like I know I want to review the code, I want to change the version of libraries and whatnot. And then you essentially get a coding agent at your disposal. Going forward in the future, we also want to make this shareable inside your company, for example, and allow those agents to interact with each other, interact with different tools, like do web search or whatnot. So basically, again, as I said, we just went public, but we are sort of doubling down on the agents. And yeah, again, in the future, you would be able to just constructing your own pipelines with the agents you defined yourself inside the IDE, pretty much. Yeah, and on the data privacy side of things, so, well, first of all, we currently undergoing ISO 27001 and SOC 2 certifications. So for the security side of things, we also don't don't store your code base on our site. So whenever we need to get any pieces of the code relevant to your question, relevant to your request, we get them from your local copy. And it's only exists in memory. So we don't save it to any file system and whatnot. Once we process it, we discard it, and we don't save it on our side. Sure. I think there was a question over there.
So if I understand correctly, you will have some ready-made agents in Zencoder, right?
Yeah.
Is there any open place for free agents, like in general? Like, let's say I'm not using Zencoder, but I want to have some agents in my apps.
Yeah.
Is there like a place for them nowadays, like where I can look for them and use them? And secondly, like how do people package these agents? Because when I look at your code, all I see is that an LLM making calls to some functions, basically. But then if I want to share that agent with another agent, what's the process of like doing that?
Yeah. Well, on the first part, it's actually a good question. I am not aware of any like marketplace of the agents as of today. That's actually one of the things we want to get to in the future. So you can imagine, just you as developer developing some sort of agent, which you can share with any developer out there, and hopefully we will get there next year. Now on the second part, on the agent interaction, like just as I've shown in my example, I had some actions defined for LLM to use. You can essentially just imagine, instead of those actions, you can define agents in the same fashion. And essentially then LLM will know, okay, I have those agents at my disposal. And then in turn, those agents might also have any agents at their disposal. So basically they then can kind of call each other in the same fashion as LLM just called tools I gave it to
Right. So it's basically like an API call, but to an agent instead of a tool.
Yeah,
basically.
exactly, exactly.
Okay.
And then agent itself will decide what it needs to do, if it needs to call another agent, if it needs to use any tools at its disposal, or it maybe it already can give the answer right away.
Okay, thanks.
Okay, I think no more questions. So thank you all for coming to my talk, and I hope it was useful for you. And yeah, you are finally free to go.